In Lesson 4.3, you'll be learning how to multiply and divide monomials. Remember that the essential question for Chapter 4 is, why is it useful to write numbers in different ways? On your note sheet, the first thing you have to fill in is the key concept, the product of powers property. And when you multiply powers with the same base, you add their exponents. So a to the m times a to the n is equal to a to the m plus n. Or 2 to the fourth times 2 to the third is equal to 2 to the 4 plus 3, or 2 to the seventh. A monomial is a number, like 80, a variable, like x, or the product of a number and or variables, like 8x. The two underneath the not monomials are actually binomials because they have two terms. For example, x is one term and 5 is one term, and together they make a binomial. X squared minus y squared is also considered a binomial. We also have things called trinomials, and trinomials have three terms in them. This section is only focusing on monomials. At the bottom of page 147, we're looking at multiplying powers with the same base. And the long way to show this out is 4 to the third power would be 4, 4, and 4, three of those, and then times 5 more. So 1, 2, 3, 4, 5. So it's not some made-up rule that you just add the exponents. It's because if you wrote out all of the 4s, we'd have 1, 2, 3, 4, 5, 6, 7, 8 of them. So we write that as 4 to the 8th power. The shortcut, or the rule, would just be to add the exponents. Okay? And for this one, letter B, 6 times 6 to the negative 4. If we look at what we know about negative exponents, we rewrote that as 1 over 6 to the positive 4. Okay? And if we multiply that times the 6 right out here, if I do this longhand, I just want to show you that these rules are just not made up to confuse you. But if you in fact multiply them out, we have 1 times 6, which is 6. And then 6 to the fourth is actually 1, 2, 3, 4 sixes. Okay? And we can simplify that by saying 6 divided by 6 is 1. And so we can't just leave a fraction without anything in the numerator. So we'll put a 1 as a placeholder there. And then you can see there are 3 6's left, or 6 to the third power. Let's see how that looks in your notebook here. 6 to the first times 6 to the negative fourth is the same thing as 6 to the first plus a negative 4. 1 plus negative 4 is negative 3. And remember from last lesson that we have negative exponents move to the denominator and become positive. So the final answer is 1 over 6 to the positive 3. We also see that the way I worked it out the long way. Go ahead and try to do 1A and 1B in your notebook by pressing pause first and then press play when you're ready to see the answers. In 1A, we have 5 squared times 5 to the third, so 5 to the 2 plus 3 power, or 5 to the fifth, would be for 1A. And 1B, 12 to the third times 12 to the negative second is 12 to the 3 plus negative 2, which is a positive 1, so you can write that as 12 to the positive 1, or just 12. Moving on to page 148 at the top, we have multiplying using variables. So the variables are the same bases, and so we're still going to add those exponents. So b squared times b squared, 2 plus 2 is 4, so we're going to write that as b to the fourth. T to the negative fifth and t to the third, add the exponents, so negative 5 plus 3 is a negative 2, and again we're going to rewrite that negative exponent by writing it as 1 over t to the positive 2. Go ahead and hit pause and try to do 2A, B, C, and D in your notebook, and then press play to make sure you got the right answers. For 2a, y to the 6 times y to the third is y to the 6 plus third. So 6 plus 3 is 9, so y to the ninth. For 2b, r to the 6th, r to the negative 5th. 6 plus negative 5 is a 1, so we can write that as r to the first or r. In 2c, a to the 7th, a to the 6th. 7 plus 6 is 13. And finally, 2d, negative 6 plus 2 is negative 4. And so x to the negative 4, we're going to write that as 1 over x to the positive 4. There's a video tutor that you can watch if you like. And we're also going to do a lot more problems to practice this concept of multiplying powers with the same base. In example 3, we're adding what we call a coefficient. The number out front in front of the variable is a coefficient. And what we can do is we can use the commutative property of multiplication to rearrange that and put the 8 and the 2 together to give us 16. And then we can add the exponents of the x's. In this case, 3 plus 4 is equal to 7. On b, we have a negative 3 and a positive 2. And we can multiply those and simplify it to make it negative 6. We have n to the negative 9th and then n to the 8th. Negative 9 plus 8 is negative 1. And notice what they did with that negative 1. N to the negative 1, they put in the denominator and put it n to the positive 1. The 1's not written there because it's not necessary. So it can get a lot more complicated really quickly, but it all comes down to that basic principle of adding exponents with the same base right here, and if they have the same base, whether it's a variable or a number, you can add the exponents. Okay, so you can press pause and try to do problems 3a through 3d on your own, and then you can press play when you're ready to check your answers. For 3a, notice they combine the 5 and the negative 3 to get negative 15. And then a to the second and a to the fourth is a to the sixth. For 3b, they combine the 6 and the 2 to get the 12. Why is the b squared in the denominator? Because negative 4 plus 2 is a negative 2, and then that popped down to the denominator to be b to the positive 2. On 3c, 6 times negative 3 is negative 18. X to the third and x to the fifth is x to the eighth. And 3d, 10 times 5 is 50. N to the seventh and n squared is n to the ninth. Now we're going to introduce the quotient of powers property. A to the m divided by a to the n is equal to a to the m minus n. We're going to subtract when we divide. So for an example, 3 to the 6 divided by 3 to the second is equal to 3 to the 6 minus 2, or 3 to the fourth. Once again, it's not some made-up rule. If I actually took 3 6 times, 1, 2, 3, 4, 5, 6, divided by 3 squared, 1, 2, 3 divided by 3 is 1, 3 divided by 3 is 1, what I have left is 4 3's. And so that's why we get 3 to the fourth power. You can see where this writing out might be a little cumbersome if I had something like a to the 100th over a to the 50th. Okay, we don't want to write out all of those a's. We want to have some sort of way to quickly do the problem. But you can visualize 100 a's written out and 50 a's written in the bottom. 50 of those are going to cancel out, leaving 50 in the numerator. So the answer to that one would be a to the 50th. Let's take a look at some of these quotient of power property problems. At the top of page 149, we have example 4, and we have 8 to the 5th over 8 to the 3rd, which is equal to 8 to the 5 minus 3, or 8 squared. In B, we have c to the 7th over c to the 2nd. 7 minus 2 is 5. And C, 2 to the negative 2 over 2 squared. Well, negative 2 minus 2 is 2 to the negative 4th, and we can write 2 to the negative fourth as 1 over 2 to the positive fourth. And finally, letter D, d to the fifth, d to the negative 2, 5 minus a negative 2 is d to the seventh. Go ahead and try 4a through 4d on your note sheet by pressing pause and seeing how far you can get, and then press play to look at the answers. For 4a, we have 3 to the ninth and 3 to the second, and since we have the same bases, if you can visualize 3 written out 9 times on the numerator, and then 3 written out twice on the denominator, we could cancel out 2 of those, leaving 7 left over on the numerator, so that would be 3 to the 7th. The shortcut is just to take 9 minus 2, which is 7. For 4b, we have 7 b's on the top, 6 b's on the bottom. 6 of them cancel out, leaving 7 minus 6, or 1 b left over. You could write that as b to the first or just b. On 4c, we have 4 to the fifth and 4 to the negative 2. 5 minus a negative 2 would be a positive 7, so we'd write that as 4 to the 7th. And finally, s to the negative fourth and s to the first. Negative 4 minus 1 is negative 5, and so s to the negative 5 is actually going to be 1 over s to the positive 5. Next, on page 149, we have that key concept actually at the bottom of your note sheet. Go back a page and make sure you fill in that key concept on your note sheet. And then you do have one more sheet on multiplying and dividing monomials. I'll make a separate video for that, but you do have a BrainPop video to watch on multiplying and dividing with exponents. And again, I'll have a second video on this topic for the note sheet with extra problems.